For this video, we're going to be discussing angle relationships in circles. So, whenever we have lines that intersect in a circle, they form special angle relationships. And the angle relationships are going to be different depending on if the lines intersect in the circle or outside of the circle. So, let's take a look at something with this. So, let's talk about what happens when lines intersect inside of a circle. All right, and this is the example that we have for this is two chords. All right, so you know a chord is a line that goes from one edge of a circle to the other side of the edge, or the other side of the circle. And when two lines intersect inside the circle, the angle they form is equal to half the sum of the intersected arcs. So what that means is we've got these intersected arcs here, x and y. And this angle right here is equal to half the sum. It's equal to x plus y over 2. Also, this angle, because their vertical angles are the same. So if I said x was, say, 70 degrees, and I said y was, say, 20 degrees, if I want to figure out this angle in here, I'd say, okay, well, I do 70 plus 20 over 2, which is 90 over 2, which is 45 degrees. So anytime we have two angles intersecting inside of a circle, the angle we get is half the sum of the arcs. So let's take a look at example number 1. We want to find the value of x. So we've got x right in here, and the two intersected arcs that we've got are arc BD and arc CA. We've got this angle here. So if we think about it in just naming it terms, we know the measure of angle BED, B-E-D, is equal to the measure of arc BD plus the measure of arc AC, all divided by 2. All right? The angle is equal to half the sum of the arcs. So let's plug some stuff in and figure this out. Measure of angle BED is x. That's what we're solving for. Measure of arc BD is 70. Measure of arc AC is 170. And we're going to divide that by 2. So if we work this out, we get x equals 70 plus 170 is 240. Divided by 2 equals 120 degrees. So that is our answer. X is 120 degrees. So this arc is equal to half the angle is equal to half the sum of the arcs. Now, what happens if the lines intersect outside of the circle? When we're talking about intersecting outside of the circle, we have 3 different possibilities. We can have 2 secants, like in this example here. We can have 2 tangents, like in this example here, or we can have a secant and a tangent, like in here. And in every single one of these, instead of being the angle being equal to half the sum of the arcs, now the angle is equal to half the difference of the arcs. All right? So instead of adding, we're going to subtract. And it's always the far arc minus the near arc. So if I look at this example here with the 2 tangents, we've got angle ARN, that's equal to half the difference of our far arc, arc NKA, minus our near arc, arc AEN. All right? So it's always the farther arc minus the nearer arc. So if I said, for example, that, well, let's see. Let's say that this is 260 degrees, and this one is going to be, we'll say, 100 degrees. All right? No, this is bad. That's a bad example. Let's not do that. Let's not do that one. Let's say that this is, we'll call it 120 degrees. And we'll call this one 80 degrees. Then to figure this out, figure out what our angle is here, we say, okay, well, 120 minus 80. It's always our far arc minus our near arc, divided by 2. 120 minus 80 is 40. 40 divided by 2 is 20 degrees. So this right here, that is 20 degrees. We do the same thing on this example. Let's think of this a little differently, though. What if I told you this was, say, 35 degrees? We'll call this, we'll call it 60 degrees. All right, and we'll call this one, what do we want to call this one? 130 degrees. Well, I gave you the answer. Whoops. Let's not do that. Let's try something else. Call this one 40 degrees. We'll call this one 60 degrees. And we'll call this one X degrees. So let's try to figure out what X is. We know that the angle is equal to the far arc minus the near arc divided by 2. So we could say, okay, that's X minus 60 divided by 2 equals 40. All right, so let's solve this. Multiply both sides by 2. I get X minus 60 equals 80. Add 60 to both sides. I get X equals 140 degrees. All right, so these are kind of two examples of how we can use this relationship to solve problems. So let's look at one more example. It says find the value of X, and I've got a far arc of 80 degrees and a near arc of 20 degrees. So if I want to solve this, I know that the measure of angle BCD is equal to our far arc, arc AE, minus our near arc, which is arc BD, divided by 2. All right, so let's solve this. We know that the measure of BCD is X, measure of AE is 80, measure of BD is 20, and we're dividing by 2. 80 minus 20 is 60 degrees, divided by 2 is 30 degrees. So the measure of angle, or the measure of X is 30 degrees. Always the far arc minus the near arc divided by 2. So what's the big idea with this? Well, the big idea is if the lines cross inside the circle, it's half of the sum we're adding, okay? If the lines cross outside of the circle, it's half of the difference we're subtracting. So inside is adding, outside is subtracting. So here is your try it problems for tonight. In each one of these, you need to find the value of X.